welcome to our webinar, A Swiss Solution Towards Repair of Composites. At CompPair, we believe in a world without material waste. And what we quite like to start with is the fact that human beings, like you or me, are able to live for 80 years. But most of the products we use every day last only a few years. This is a paradox, no? And for us, that's exactly how it started, being inspired by nature to extend the lifetime of composite structures. So for today, we will run this presentation on CompPair products. You will see live demonstrations of CompPair composites as well. Then you will have a small questionnaire to answer before going to the Q&A session for an unlimited amount of time. I'm here standing up, I'm Amal Coat, CEO and co-founder of CompPair Technologies, and here with me we have today Robin Triguera, CTO and co-founder of CompPair, who will run with us the live demonstrations.
Exactly, and I will let you present the rest of this presentation, and I'll see you later for the live demo.
Great, thanks a lot. So if you're all here today, it's because you're aware of composites and the great potential and the great applications that we can find with composites thanks to their lightweight properties. However, with composites, during their lifetime, you have some problems, first of all, of design limitations because they are sensitive to damage, and then you have the choice. Either you can repair the damage that will appear to composites, and this is a cumbersome process that costs really a huge amount of money, and the global industry is really enormous. Then on the other side, and this might be your case as well, for many applications, what you would do is just replace parts. This generates a very high amount of waste that for many of them are not recycled at all. So this raises big question of lifetime management on one side and sustainability on the other side that we are answering with CompPair by bringing those solutions and reduce your maintenance cost and help the environment. What we are bringing as a solution is textiles, carbon glass textiles that are pre-impregnated with our resin chemistry, and it's more than a prepregs. It leads you to a smart composites. So what you will do with those prepregs is first manufacturing them, producing full composite parts with our prepreg products, and what we aim for is to have a full compatibility for you on your manufacturing line. Then what we are bringing when you will produce those composites is a better crack resistance, and you will have the ability to fully regenerate the damage multiple times, and most importantly, extremely fast. At the end of life, and this is why we are providing a 360-degree solution, is an improved recycling. To demonstrate such technology, what we have done is to run several demonstrations, but specifically that one, which is typical of the aerospace industry. We impacted it, and here you are able to see a typical damage. So for you, this might be critical, and we know that this is critical because it will just grow into a larger damage. And you will spend normally several hours to repair it with our solution. This is simple, 150 degrees for 1 minute, and it's done. You recover fully the mechanical properties. With such technology, we are bringing now those prepreg products. This is the first product family that we have as carbon or glass fiber prepregs, pre-impregnated with one typical resin chemistry. And here I have an example of those prepregs that are twill or UD glass or carbon textiles. For you, what you have is a standard manufacturing that we are providing with this first family of product of 140 degrees for 3 hours. Of course, this is a first product family, and what we aim for with this technology is to target the entire applications that you can find with composites, and those are just typical examples where we could implement CompPair at a later stage with all our different families of products. So now I think it's time for you to just go for a demonstration to see it from directly your eyes. And what we will do for this demonstration is go, first of all, on a first step, an impact that will be made with a steel pétanque ball, and then run the assessment of damage thanks to an NDT machine or visual assessment, and then at the end, the repairing process that takes only 1 minute with our case, and then we will assess how damage is healed thanks to that on carbon and glass. And for that, what I will do is just go for the other camera. So we will shift the camera right now so that you can see the demonstration and Robin running those demonstrations.
So I have here the glass plate and here the carbon plate. I will impact them, as Omel said, with this steel ball. I have a small plate to protect the floor as well. Let's not waste more. Let's impact. So normally you will see an impact in this area on this glass plate. I do the same with the carbon plate. I will need just to be a bit more precise this time. And here we go. So I hand the plate to Amel.
The typical suitcase that we have built for that, where you see different plates, but especially different shapes that we have manufactured, like a corner in here. And what you will be able to see in here is here a typical damage that you can see in here, which is a delamination that will just grow more and more and more. And what we will do now is bring a typical heat gun that I have here in my hand that you can just see. And what I will do is come onto the damage. So you see close the damage, and I will run the heat gun here. And with the heat gun, what you will see is typically here, in less than 1 minute, we will see suddenly that the temperature is well reached on the damage. And when the temperature is reached, what you would see is that the damage has completely disappeared. So I will let you know when the temperature is okay. It's on my screen, it will be green. And we are soon okay. Yes, we are good. So what you see here is that the damage has completely disappeared.
So I have here the empty machine provided by ProSec. I have here a probe with 64 elements. I have put a bit of gel on my plate, the same kind of gel you would put for an echography. And basically we are sending ultrasound and recording the signal we get back from the plate. And it's showing here with this red to blue scale. And when it's red, we have like a strong signal. And we will lose this signal as we swipe over the defect. So I'm swiping the plate, trying to find the defect. Here, you can see it, I have it here. And yeah, we see that it's time-based. So the screen is shifting. What I will do is to record while I swipe over the damage. And this way we will be able to spend a bit more time on it. Okay, now I can save the file. Just need a DAM, maybe can call it this way. You know, it's our damage. I save the file and I reopen the file then. Okay, and here we have the typical L scan, A scan, B scan, and C scan. We'll go on the C scan view to see a bit better. I will enlarge it like this. And I can also zoom a bit on the default. You can see that it has the typical shape. I now select the freehand cursor so we can measure the impact to really assess what is its size. I'm moving the cursor, you can see it here. And as you can see, we are around 15 millimeters of impact. I can give back the plate to Amel so we can clean it before we heat it. Otherwise, we will just dry the gel on it. And you can really recognize the typical shape we had also with the glass plate. And it's also, as you may notice, quite similar size as we have impacted it in the same way with the same pattern ball. And now I think that we are almost ready with the plate. It's dry. And yeah, really the beauty of this NDT testing is to see through this carbon. It's a thin plate, but we can still really see well the defect. Heating the plate. So it's exactly the same process as what we've done with the glass plate. The same heating process is going on. We are increasing the temperature. We heat the fibers and the matrix as well you may know that carbon is more conductive than the glass, so the heating is a bit different, but the result in the end will be exactly the same. So we just need to heat it up. Then this time we cannot go directly back with the NDT machine on the plate as it's hot, so we will need to wait for it to cool down. It will take a bit of time, so we will continue the presentation after that. And you will see me also with this typical thermometer, check the temperature of the plate while it's cooling down, and I will put it in water at the end to be sure that we effectively reach the right temperature.
So you have seen how we can heal most efficiently those composites, and most importantly extremely fast. But something that can be really important for you is also to see what are the performances of those composites in typical mechanical properties. So what we have done is to assess the mechanical properties of CompPair composites into tensile, into bending properties, but also compression after impact or even fatigue, to see how they perform. And so what we have done is to run those tests, and we just want to present you a few of them in here. The first one is typical flexural properties, where you see here on the left flexural modulus for CompPair composites, a typical carbon 2-2 twill with various fiber qualities that we have assessed for this graph. And then what we've done is get the comparison with typical industry benchmarks that we could find into various data sheets for typically the marine and sports and automotive industries. And so what you see is that CompPair composites match completely industry requirements. We've done exactly the same for tensile setup. Here you see the tensile modulus for CompPair composites in comparison to industry benchmarks. And then at the end, what we have said at the beginning is the fact that we have a better crack resistance, so better toughness of those composites. And you see here typical toughness value G1C for, again, CompPair composites higher than the industrial benchmarks that we could find. Here, what you have seen is a demonstration of static damage and repair of those damage typically after an impact. However, into typical application, what you would find is fatigue damage, so cracks that are growing over the time due to the different stresses that are applied onto those structures. We have tried and we have done the reproduction of those cases, exactly that onto some tests. And what you see here is a typical modulus on the left for different healing cycles. And what we have done was to take the sample and get some fatigue testing, and then see how they can recover damage after they are damaged at a 90% probability of failure. We stopped the test, we healed the samples, we redid the test again, and what you can see is the fact that for standard composites in red, this is a failure after 2 cycles. And for CompPair composites, basically, you can highly extend the lifetime of the composites for a lot of time as compared to standard composites. To finish this webinar, what we want to do is just give you a bit about us as well. We are a young company, and we just want to share with you our history, but also our vision for the future. This technology and those new products are based on deep research run at the Polytechnique Fédérale de Lausanne in Switzerland, and we reached a breakthrough in 2018, then assessed the opportunity and scaled up the product, run various demonstrators. We validated the market as well early this year with validation of the product as well and the properties that you have seen in here. And we also got various awards, and especially we just got awarded the Solar Impulse Efficient Solution Label. We are now today in here with you, with our sales, but we are in parallel as well fundraising. We're a young company, and what we want to do is extend the product portfolio to best meet the various application needs that you would have. Most importantly, we are growing right now a wonderful team in a time of crisis, and we really hope that for you as well, it's going well in those difficult times. We were speaking about the different products and the extension of the product portfolio. We are bringing now one first family of product that is adapted most specifically, of course, to high performance marine and sports application, but our aim is to grow this product portfolio in order to best meet the various application needs, and our aim is to grow further in those various applications, and we are already started right now the development. So if you are interested into that, do not hesitate to contact us. We are more than happy to get in touch and to have further discussions to assess the different synergies that we could have. Finally, what you would be interested in, I guess, is to know what we provide. We provide, of course, things from the implementation to the end product. We provide at first the prepregs with various architectures and fibers, but after that, we are also here with you to have custom design, but also contribute to the implementation setup. Then, of course, customer service, but most importantly for such a new product is to provide repairing process support in terms of heating the plate when you would need to get the repair, even if it's really easy, and then also assessing the damage with the NDT machine or simply by visual assessment. With that, of course, we are not just only Robin and myself, we are a wonderful team running all that venture with also Veronique Michaud, scientific advisor, but we have Cecilia also on the side of technology, Camille on the side of business, and we have Bertie and Nicolas that you might have contact with them after this webinar. With that, I would like to close by sharing with you our vision is really to provide with those solutions full circularity to the composite industry, going from the production and use phase that, of course, you are used to, but then you have issues in terms of damage. If damage appears to the matrix, we are able to heal them, reuse the part again. If damage appears to the fibers, we can recycle them, reproduce them again, closing the loop. And such circular economy model have demonstrated the potential to save a huge amount of resources into composites, which is totally in line with the Sustainable Development Goals. So if maintenance costs are an issue for you, if sustainability is a high concern for you, we really hope that you will join us on this impactful journey. We would like to end to thank the different support we have, the different companies we in close touch with, the Composite United Network for their support into this webinar, Prosec as well for the support into the NDT machine. And right before going to the Q&A, let's head back to Robin to see if the damage is well healed onto the carbon plate.
Applied already a bit of gel on the plate, and we can look also at the C-scan, same as before. You remember this typical shape of the damage we had here. I can swipe over the plate. It's a bit different in terms of color because the intensity changed a bit as it's not completely cold. Have like modified also a bit the gain, but as I'm swiping, you can see that we don't have this typical shape we are looking for. I'm sometimes lacking a bit of gel, I think, but we are really not seeing this default anymore.